Welcome to part one of our lesson on concurrent programming with services, where we focus on the intent service framework. After completing this part of the lesson, you'll know why Android services often require concurrency. You'll also recognize the motivation for Android's intent service framework. And finally, you'll understand how the Android intent service framework can simplify the programming of concurrent started services. Let's start out by giving an overview of the motivation for service concurrency in the first place. By default, a started service runs in the main thread of its hosting process. In particular, it does not create its own thread and does not run in a separate process by default. As a result, service lifecycle callbacks will occur in the UI thread, which is sometimes also known as the main thread. Of course, a service that performs long duration or blocking operations in the UI thread or main thread may therefore incur the dreaded application not responding errors, also known as ANR errors. One way to make a service concurrent is to use different processes. This example here shows two different processes with a different thread in each one. These types of configurations can be controlled by the Android manifest.xml file, as we'll discuss in more detail in the next part of this lesson. Unfortunately, however, creating a process per service can end up using an excessive amount of system resources. Let's now talk about the motivation for the Android intent service framework. A multi-threaded service must be programmed rather than configured via the XML file we just talked about. You would typically do this by starting a handler thread, executing a task via the Java executor framework, and so on. However, developing concurrent services in an ad hoc manner can be tedious and error-prone because there's lots of accidental and inherent complexities involved with concurrent programming. For example, shutting down a concurrent started service can be very tricky, as we'll talk about in our next module on Android local communication. We therefore need some way to automate and simplify the programming of concurrent started services. The intent service framework is an easy way to create a concurrent service. Let's talk about the intent service framework and how it works in Android. Intent service concurrently handles commands that are expressed as intents. One of the nice things about doing this is it eliminates the need to write ad hoc concurrent services for a wide range of concurrent service applications. An intent service is a framework that's implemented internally by extending a started service, as shown here. You can see that intent service extends service. It's very easy for apps to use. Subclasses of intent service simply need to override the onHandleIntent hook method in order to process an intent concurrently. OnHandleIntent runs one call concurrently at a time outside of the main thread of control. So it's running essentially one process, it's processing one intent in a background thread at a time. In contrast, if you need to be able to process intents in a pool of threads, you might choose to use Java's executor framework, things like the executor service, which allows you to be able to process intents in a thread pool. However, it's much more tricky to shut these threads down when the service is finished, as we'll talk about later. Let's now talk about the structure and functionality of the intent service framework. Clients send intents via calls to start service, just like they would do for any other type of started service. Here's an example where a client calls start service, passes in an intent, and of course this intent can be imbued with data, either by calling the setData method to set the data in the intent, or by adding extras into the intent. The intent service itself, as always, is started via the activator pattern on demand by the Activity Manager service. This pattern efficiently and transparently automates scalable on-demand activation and deactivation of services accessed by clients. Switching our focus now from the activity side to the service side, an intent service subclass overrides and implements the onHandleIntent hook method. This hook method is used to process the intent in a background handler thread. This thread is different from the main thread or the UI thread that's being used to run other types of computations. Under the hood, the intent service uses the hammer framework to dispatch the onHandle intent hook method in a background thread. You can learn more about the hammer framework by taking a look at this video, available on my YouTube channel. The Pong service app, which we'll be covering shortly, overrides the onHandle intent to do a couple of things. In particular, it's used to update the status bar, and then it's also used to send an intent back to a ping receiver that's running in a different part of the application. All the details of handling the intent concurrently are hidden from application developers or service developers by the IntentService framework. We'll now discuss some of the IntentService usage considerations. The intent service can be used to simplify concurrent handling of commands that are passed as intents. All you need to do is override the onHandle intent method and process an intent concurrently. Naturally, other fields and methods can also be provided by subclasses of IntentService. Another nice thing about this is there's no need to be able to handle runtime configuration changes in your application, because those are pushed into the service rather than having to be handled via other means with the activity lifecycle management hooks. As a consequence, the complexity and power of the model view presenter or MVP pattern may not necessarily be needed if you use services. Of course, a subclass of the intent service can still only interact with the user in very limited ways, as we'll see when we talk more about our ping pong service receiver application. If you want to run the service in another process, you can simply provide the Android process directive as part of the service element in the Android manifest.xml file. However, in many cases, using a separate process may be overkill, as we'll discuss in the next part of this lesson. One of the key drawbacks to using the intent service is that only one intent at a time can be processed, because they're queued up in a message queue using the hammer framework, and a background thread pulls each message out of the queue one at a time and runs it in the background thread. This therefore limits the scalability of the intent service on multi-core platforms, where it's actually possible to run multiple things simultaneously. Therefore, services that use thread pools can be applied to make the service more scalable. However, they're harder to shut down, as described at this link. The Android intent service is widely used throughout Android's packaged apps. You can take a look here for some of the many examples of using intent service throughout Android. And I strongly encourage you to take a look and understand how it's used within the Android platform for a variety of common and relatively simple concurrency needs. This concludes part 1 of our lesson on concurrent programming with services, which focused on the intent service framework.